All right, now, if you have a function that you cannot use any of the algebraic techniques on that we've talked about, we can't factor it, it's not a square root where we can multiply it by its conjugate, then we have something that's not pretty. So we go back to a table. So here's one that's not pretty. The limit as x approaches 0 of 1 plus x raised to the 1 over x. And if you guys would have a look at the graph and have a look at the table in your calculators for this and just make numbers very close to 0 and see what you get. Pause here and back. Here's my graph, and you can see as x approaches 0, it's 2 something. So it's better to look at the table on this one. And as I get close and close to 0, that's that 2.7 number. Does that ring a bell to anybody? I believe that was our value for e. And in fact, that is the definition of e. The limit as x approaches 0, 1 plus x raised to the 1 over x. And there we have e. Isn't that nice? Okay, so use your calculator for those. Okay. One-sided limits. Sometimes you'll approach just from one side. You'll know that it's a one-sided limit. Let's say they'll have the limit as x approaches 0. From the left, it'll be a negative sign up there. And then from the right, limit as x approaches 0, and they'll put a positive sign there. So left and right. All right. So let's look at the limit as x approaches 0 from the left of absolute value of 2x over x. And I want you to do it graphically and numerically. Use your calculators and pause here and I'll wait. All right, if you're back graphically, you should have seen on the negative value we were coming in at -2. So from the left, as we get close to 0, it's -2. And of course you saw on the right it's +2. But we don't really need that part. We only want the left side. So graphically it shows that it's equal to -2. And then if you used your table, and you got numbers very close to 0, you saw that they were very close to -2. Actually, they were all -2. Okay, so graphically and numerically, there's no rationalizing on these or anything. We just use our regular techniques from section 1. All right. Now, if f is a function and c and l are real numbers, then the limit exists only if both the left and the right hand limits agree and are L. Okay, so in order for a limit to exist, both the left hand and the right hand limits have to agree. So we say the limit as x approaches c of f of x equals L. And let's see if that's going to be true for this little example here. As x approaches 1, f of x equals 4 minus x and 4x minus x squared. And I think this one's going to be pretty fast. So pause here and try it. All right, and I'll show you. You can just substitute because there's no there's nothing stopping you from substituting. So they do agree. So yes, the limit as x approaches 1 is equal to 3. Okay? You just have to test it and see if it's going to work. All right, here's our friend. Remember our friend, the difference quotient? All right, now the difference quotient has a problem when we look at the limit as h approaches 0. You'll notice the h goes to 0, which we're not allowed to do. So, if you remember from the beginning of the year, our h's canceled out. And that's what we wanted. So now we're going to cancel out. All right? So we're going to find the limit as h approaches 0 of f of 3 plus h minus f of 3 if we use the function f of x equals x squared plus 1. Okay? So we're going to do this in a few steps. The first step is to find f of 3 plus h. So plug that in to f of x, and I will pause here and wait. All right, I get x. Oh, shoot. Now I get 3 plus h squared plus 1. So that's 9 plus 6h plus h squared plus 1. So 10 plus 6h plus h squared. All right, now find f of 3. F of 3 is 3 squared plus 1, which is 10. If I subtract, I get 6h plus h squared divided by h. Simplify, and I get 6 plus h. And now I can use the limit because I don't have a denominator anymore. The limit as h goes to 0 of 6 plus h is just 6. Okay? So remember, you go through your steps, find the first one, find the second one, subtract them, simplify it, and then find the limit. All right? All right. Try out all your new algebraic techniques on 12.2.